All right, we're gonna go ahead and get started with your exit ticket for yesterday. So we're starting with passage 5, and we're gonna just move straight to the questions. So number 23, I'm gonna do 23 in orange. Of the wires tested, resistance increases for any given material as which parameter is decreased. So for any given material means you're just going to look at the materials at a time. So resistance increases. So resistance, let's see. Increase, 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 increase. So these are separated into two different lengths, by the way. So we're just going to do it like that. Increase, increase. Increase, increase. So we can look at that. And now as which parameter decreases? So this doesn't change, but that decreases. That decreases, decreases, decreases. Okay, so what's this one? Cross-sectional area. That one's B. And this one is an IOD question because it's asking you to pull numbers out or trends out from a table. So do you see here, this goes up as this goes down. This stays the same and this stays the same, so you don't even really have to do as much as we did. But I was just trying to be thorough because these stay the same. So this is really your only option here. All right, number 24. Given the data in the table, which of the following best expresses resistance in terms of resistivity, cross-sectional area, and length? So this is actually IOD 504. It's a math problem. So you actually have to, and there's a 602 level problem that's similar to this as well, but it is calling out the relationship. So expresses resistance in terms of resistivity, cross-sectional area, and length. So 46 is some relationship, and you just got to test it. So 46, let's see, equals resistivity 2.44 to the 5th-ish power divided by length divided by 1, 2.4 to the 5th power. No. Let's see. This one would be 46 equals 2.44 to the 1st power over the area. 2.4 divided by anything is not going to be 46 unless it's a, well, and divided by any number more than 1. So we can cross off G. Let's see. 46 equals 2.44 times 5.26 times 1. 2.5 times 5, or 2 times 5 is 10, so no. And 46 equals the area 5 times 1 over the resistivity, which is 2.44. 5 divided by 2 is not that. Okay, so the answer to 24 is, whoopsies. Oh wait, I lied to you. I switched these two equations. Just kidding. These two. I switched the answers. It is G. Okay, so this one, there's like no shortcut for this. This one is a math problem. So when you see something that's like this is probably one of the hardest problems you'll see. You will only see this once or twice on the ACT at all. So again, not that one. It's G. Okay, 25. Which of the following wires would have the highest resistance? Okay, so highest resistance. Let's see. So highest resistance on the table is made of iron, but is that an option here? No. So that's a key point that people get wrong all the time, is they're like, because it's not saying which has the highest resistance, it's which of the following. So aluminum wire with a cross-sectional area of 0.33, 2 centimeter aluminum wire. So let's look at aluminum versus tungsten. Aluminum, 53, 216, 105, 4. So it's going to be tungsten because this is higher than aluminum anyway. And now let's see for tungsten. Is a 1 centimeter wire higher or a 2 centimeter wire is higher? a 2 centimeter wire is higher. So the answer to 25, then if you cross this out on the table, like look, which ones are higher here, which ones are higher here? So it's going to be this half of the tungsten table will get you your answers here. So the answer to 25 is D. This is, again, an IOD problem. All right, 26. According to the information given, which of the following statements are correct? That's an EMI question. Anything like this is always EMI. If you see those conclusions. 10 gauge wire has a larger diameter than a 16 gauge wire. Let's see. 10 gauge wire, 2.5. So yes, that one from the picture. Gold has a higher resistivity than tungsten. AU, 2.44. Tungsten, 5.51. No. Aluminum conducts electricity better than iron. So let's see. How do we know how well it conducts electricity? Resistance is the extent which it opposes the flow of electricity. So low resistance equals more electricity. So let's see. Aluminum conducts electricity more than iron. These numbers are lower, so that's a yes. So that means the answer is 1 and 3. So 26 is J. And your last and final one. Which of the following graphs best represents the relationship between resistivity of tungsten wire and its length? This is IOD. It's asking you for a trend. So, tungsten again, resistivity and length. Tungsten, this is 5. That stays the same no matter what the length is. So, if that is resistivity versus length, here we go. This is always going to be the same even if the length increases. So this was 5.51 the entire time. That is D. So that's all I got for today. That's all she wrote, folks.